Bismillahirrahmanirrahim. Assalamu alaikum. Okay, let's start chapter 11 of T2, which is trigonometric ratios. And before doing this chapter, we have done Pythagoras theorem. And the Pythagoras theorem was about, obviously, right angle triangle. And it gave us the relationship between the sides of the right angle triangle. What we studied in Pythagoras theorem, the side opposite to 90 degree is hypotenuse. Okay. And then we have another angle over here, A. The side opposite to this angle is perpendicular. This angle here, A, has two adjacent sides. One is hypotenuse and one is base, right? This was what we did in Pythagoras theorem. And the Pythagoras theorem relationship was hypotenuse square is equal to perpendicular square plus base square. So that was all about the Pythagoras theorem. Now coming to the trigonometric ratios. So trigonometry is also a study of the length of the sides of the triangle and angles. We'll be talking about the right angle triangle, but now we are more interested in angles and the length of the sides. And to discuss these things, we need ratios. And those ratios have specific names as well. Okay, so this study is all about those ratios, and this study is normally known as trigonometry. So let's do that. Okay, now we have this angle A, right? Now this angle A, to study the ratio for this angle A, what are we going to do? We are going to do trigonometric ratios, and for that, two sides of a triangle are going to make a ratio, and that ratio is going to be known as what? This is what I am going to let you know. Okay, so the first ratio is between the perpendicular and the hypotenuse. If the first ratio is perpendicular and hypotenuse, and this ratio, perpendicular over hypotenuse, with reference to this angle A, is known as sine of angle A. Now this sine is name for this ratio, perpendicular over hypotenuse. Whenever we are taking this ratio, perpendicular over hypotenuse, it means sine of angle A, which is also written as sine A. Usually it is written as like this. Now this is the angle A, and this angle is equal to the ratio of the two sides. Okay. Now if we change the side, if we take base over hypotenuse, now this ratio with reference to this angle, again this angle, is known as cosine of angle A, and is usually written as cos A. Now if we are considering base and the hypotenuse, now that is going to be known as cosine with reference to this angle. And don't forget that we are referring to this angle A, and it's a right angle triangle, right? Okay, now coming to third one. If we take now, we are taking two sides, okay? There are three: hypotenuse, perpendicular, base. We have taken perpendicular and hypotenuse, we have taken base and hypotenuse, right? Now it's a time to take perpendicular and base. This is called tangent angle A and is known as tan A. Okay, so we have ratios of the ratio using two sides of a right angle triangle, and each ratio has a specific name. There are three more ratios. If we take the reciprocal of these ratios, we're going to have three more ratios like cosine, cotangent. But we'll for the right now, for the time being, we'll stick to these three ratios, and we'll talk about these three ratios. We'll discuss cosine, cosecant, and cotangent later in some session. Okay. Okay. Now let's take an example, and we have a length of each side, and how we are going to deal, how we are going to use those ratios. Okay, let's do that. Okay, the triangle is the same, but now I have the length of each side. Hypotenuse is 15 centimeter, perpendicular is 9 centimeter, and the base is 7 centimeter. Now, how to represent each ratio with reference to this angle A? So the first ratio is sine A. And what is that? Perpendicular over hypotenuse. Perp over hypotenuse, which is 9 over 15. Okay. The second ratio was cos A, which is base over and this is 7 over 15, and then tan A is perpendicular over base, and it is 9 over 7. So these are the ratios, right, with reference to angle A. This was how we are going to take these ratios when the length is given. Okay, let's move further, and let's take some example and some unknown side, and let's start digging how the things are worked out. Okay. Okay, let's take some further example. Okay, the triangle is the same. Now this angle is 30 degree. Okay, length of the hypotenuse is given 10 centimeters. I need to know the length of the perpendicular. Now there is one way, of course, because in right angle triangle you can apply a Pythagoras theorem and you can do that. But again, coming back, now two sides are unknown. Okay, so if you apply Pythagoras, you won't reach anywhere. Okay, now coming to the trigonometric ratios, we have angle, we have one side. So if I want to find the unknown, which is perpendicular, which ratio has perpendicular and the known side, which is hypotenuse? Perpendicular over hypotenuse is, what is it? The name of the ratio? Sine A. Okay. So perpendicular, I'm writing again and again so that it's easy to remember. Okay, spelling wrong, is sine A. Now let's put the values. What do I have here? BC. Okay, what do I have here? AB is sine 30. Okay, now what is BC? It is X. I need to know. What is AB? It is 10 centimeters. So, and sine 30. You can use your calculator and you can find the value of sine 30. It's pretty easy, right? So the sine 30 is 0.5. Now, what is x? So x is equal to 10 into 0.5 and it is 5 cm. So this side is 5 cm. Okay? Right. Now, the same way, I need to know what is y. Now, for the y, the side is changed. This is base. Okay? It's not a perpendicular. And now I have to consider the ratio which includes base and hypotenuse. This is base, this is hypotenuse. So base, let's mark a line over here so that. So base over hypotenuse, again wrong spellings, is equal to cos A. Okay. So y is over 10 is equal to cos 30. So y is equal to, the cos 30 is 0.86, 10 into 0.86. You can apply the calculator and you can find out the values. So y is 8.6 cm. So I have this value, 8.6 cm. Pretty easy, right? So using this angle and this given side, I have the unknown sides. Okay. Now let's assume that I need to know, I have these given sides. Okay. I have hypotenuse, I have perpendicular, but the angle is not known, right? I can do that. So let's calculate that, and how to do that. How to calculate the angle which is not there. Okay, so let's do that. Okay, same triangle, I have the given sides. We have just calculated these sides. But now angle is not known. What do we do? Okay, let's take the same two sides. Perpendicular over hypotenuse, which is BC over AB is equal to sine A. Okay, this is 5, this is 10 is equal to, now sine A, right? Not known, sine A. But I need to know what is this A angle, angle A. Need to know angle A. Okay? So I have to take this sine to the other side. So going to take inverse for this ratio. How to do that? What I'm going to do is A is equal to, remember this. Okay, I'll write it again. Sine A is equal to 5 over 10. Just change the sides. Okay. Now this sine is going to the other side. I'm going to take the inverse of this sine with reference to this ratio. How? A is equal to sine inverse 5 over 10, which is sine inverse 0.5. Again, you can use your calculator, maybe it's working with shift or something. You can use inverse of sine and give the value, and you will get here 30 degrees. And we are back to what we needed. Okay, when we did the previous example, the angle was there. Now the angle is not there. Similarly, you can use the other two sides. You can use tangent, like perpendicular over base, right? And then for that, what you are going to do, I'm going to just write over here, and you can just then calculate it. It could be for the tan, perpendicular, which is BC over AC is equal to tan A, and then 5 over 8.6 is equal to tan A, and angle A is equal to tan inverse 5 over 8.6. Now, you can just use the calculator and find it out. You can use any of the ratio which is possible according to the given conditions. Okay, so hope you got the idea of the trigonometry ratios. We'll do some more examples in the next session. Thank you very much for now. Bye bye.